If you'd like to just share your slides, please, and start when you're ready.
Okay, good evening all. Thanks for joining. Thanks to James and Siobhan for organising this, and thank you to GIA for having me. So you've probably heard of this project. It had a lot of coverage, especially around COP26 back in November. This is 107 Niddrie Road, and it's a typical red sandstone Glaswegian tenement that us at John Gilbert Architects have been retrofitting with the intention of getting up to NFIT standard. So firstly, to put it in context, the whole block is owned by Southside Housing Association. They own all 8 flats in the close, and all of the flats were actually void for about 2 years, which is quite a rare selection of circumstances, I would say. There's not many other tenements in Glasgow that I can think of or that I've ever come across that are all in the one ownership. As you'll see as we go through this, that gives us a really good testing ground for this pilot project. So to put it in context, Each 2 is the typical or the go-to standard at the moment for local authorities and housing associations. That is a requirement that social housing is improved in the coming years to get it to EPC band B by 2032, which is obviously fast approaching, and that's with a further target of 2045 being net zero, and that's with all other tenures being approximately EPC band C by roughly 2030. So obviously Southside had the option. They could have just done that. They could have done the bare minimum to get them to Each 2, and that would have been them sorted. They did get additional funding from several bodies, the Scottish Government being the main one, and I think Glasgow City Council also contributed. And I think they were obviously getting more funding the further they push things. So there was obviously that incentive there to push things as far on as we could go. The other sort of reasons for that were our main concerns in terms of, if we aim for the bare minimum, is it enough? Are we going to change things enough to make any impact on the climate emergency, on fuel poverty, and also in reducing the performance gap, which I'll get to. So as you can see from this graph, our current carbon emissions are exceedingly high, only on the way up if we continue as we are. And I'm sure, as we all know, we all need to change our living habits rapidly if we're going to get towards a net zero future. And it has to be a pretty drastic change if we're going to make any difference. So we should be striving for the best, and we should be trying to do as much as we can, whenever we can. Net zero gets thrown about a lot, and I'm sure you all get absolutely plastered with it if you ever go on social media as well. But we're actually talking about 10% of current consumption rather than absolute zero. And then this graph is quite terrifying. It kind of it shows you certain countries or certain groups of countries with their current emissions per head, and where we all basically need to meet at this little node and then project into the future, getting as close to zero as possible. There's a lot of changes got to come, which I'm sure we're all aware of. In terms of performance gap, if we are going for Each 2, which is basically the bare minimum for a housing association, EPCs are obviously generated with SAP, which is pretty inaccurate at the best of times. And within those bands of the EPC ratings, the variation in actual energy consumption is huge. So you can see here that a C ranges from really low down here all the way up to here, and then you get the same for each layer. So we actually, it's really hard to kind of do the right thing when we actually don't accurately know what we're talking about in some cases. So yeah, we decided quite early on that we wanted to push for Retrofit, and this was going to be a pilot project, and we would all learn lots and then apply it to the future. Glasgow has about 80,000 tenements, pre-1919 tenements in it, and there's approximately 180,000 in Scotland. So this learning that we've picked up along the way here needs to be disseminated quite quickly, so us as architects and construction professionals can get to work basically and improve our housing as quickly as we can. So even if we do decide to strive for Retrofit, which is obviously done through PHPP, as with a new build passive house would be, there's still that performance gap. And you can see here, this is each blue bar is a passive house, and some of them are operating considerably better than they're meant to, and some of them are considerably worse. So our argument here was that the research and the sort of monitoring post completion is just as important as all the design and construction parts of the project. So Niddrie Road actually does have a huge research budget, which is being led by Tim Sharp at the University of Strathclyde. So him and his team have already installed monitors and sensors throughout the flats, which will be monitored for about a year at least after the project's complete. And I think that there is an element to that research where it'll be disseminated to those who want it. Okay, so this is Niddrie Road. This is 107 Niddrie Road. It's 8 one-bedroom flats, all owned by Southside. They were all vacant, and we've got a party wall with the adjacent flats to the left in that picture, where there are 4 flats, and then we've got a single ground floor flat on the other side, which gives us a front elevation, a full rear elevation in the back court, and then this sort of like partial gable elevation on the right here. In terms of the location of 107, it actually doesn't sit in a very helpful position. It's the south elevation is actually southeasterly facing. It's heavily shaded by trees and neighbouring tenements, and obviously in terms of Retrofit, those passive solar gains through your glazing are really important, and we're not really getting much here, so it was always going to be quite a tricky one. But this is Niddrie Road running diagonally across the screen here, and then top left, that is Pollock Shores Road, just if you ever want to go and visit. So this is it in plan. As you can see, it's shaded by the buildings, shaded by the trees, some of which were agreed would be removed to assist in those solar gains. So originally, the scope of works involved all of the sort of energy efficiency works and some basic building maintenance works. But as you'll see as we go through the presentation, these things kind of grew arms and legs pretty rapidly from the outset. I think it's probably pretty typical for a building of this age. You start opening up one thing to do one job, and then you find 3 more things that you've got to fix and repair. And originally, all of the internal plaster, all of the original ceilings, everything was meant to stay. So it was never included in the budget or the design. Just as a quick side note, at the same time that my director Chris Morgan and myself were working on this project, we were also working with Cedar to develop this designer's guide to indoor air quality. And basically it's a fascinating but terrifying read, because it basically says, as we're all making our homes more airtight, we're then sealing in all of the toxins and off-gassing from plastics and your UPVC windows and your carpets and everything. And basically everything in your home is trying to kill you is a sort of dramatic tagline of that. But really worth a read. I highly recommend going to the Cedar website, and you can download a designer's guide, which is much thicker, or you can get a home user guide, which is like a much more stripped down version of that. And just to clarify, they're about maintaining indoor air quality in airtight homes, which Niddrie Road will be. Okay, so as you can see here, these areas of brickwork in this photo were remedial structural works. I think there's this conception that old historic buildings have been crafted beautifully, and the guys that did it are way more skilled than tradesmen are today. And I having seen some of the stuff on Niddrie Road when it was opened up, I don't know if that is strictly true. There was huge amounts of structural repairs needed on this that were never ever included. This little central pier in the photo here with the brickwork, that was balancing on this totally destroyed piece of stone, which it was just dangerous. And there was huge areas of brick internal walls that weren't even tied into the stone, so you could just like move the whole brick wall. It was pretty in pretty bad shape and needed a lot of care and attention. So for those who aren't fully up to speed on Passive House or Retrofit, there are kind of three main things that we consider early on, and that is insulation, airtightness, and ventilation. I think if you were to walk down the street and ask anyone, what would you do to improve your house, make it more energy efficient? I think most people know that insulation, put it in your loft, put it on your walls, put it in your floor, it's going to improve things. But it's about doing it in the right way. It's about using the right materials. And it's also about minimizing thermal bridging. You see so many houses that have had EWI applied to them, and they've just stopped it at ground floor level. So you've got a cold wall foot. And yeah, it's quite saddening when you see how badly a lot of retrofit is done. And we're only going to have to go back and redo those in the coming years, because we already know that they're not performing the way they should be. Airtightness, typically in a new build, this would be done with membranes. In Niddrie Road, we were really keen to use natural, traditional products where we could. So in this case, we used a lime-based parge coating applied directly to the stone internally, and that seals the face of the stone, giving us the airtightness, but it also allows the stone to breathe. We always use natural materials whenever we can, and they tend to perform better than the man-made plasticky products. The final thing on here is ventilation. So each one-bedroom flat is getting its own dedicated MVHR unit, which is located above a drop ceiling in the bathroom. And for those that are not aware of MVHR, haven't used it before, this allows you to have all your windows closed, and you can bring in fresh air and exhaust your stale, moist air, but there's a heat transfer. So you're not pushing any of that heat that you've paid for out of your building. So it greatly reduces your energy demand. So we applied lots of energy efficient measures at Niddrie Road. We've got wastewater heat recovery units under the baths. 4 of the 8 flats have got air source heat pumps. The top floor flats have all got new energy efficient gas boilers. There was a huge amount of stone repair. It was all cleaned and repointed by stonemasons. We did improve the internal layouts while we were on. The original layouts were crazy. To get to the toilet, you had to pass down a sort of 500 mil wide corridor just to get to the toilet. So yeah, we got rid of that and improved it. We protected a lot of the original timbers, insulated the loft, insulated the ground floor, insulated all the external walls, and we've installed new timber frame, triple glazed, Passive House rated windows. This is a Matterport model which shows the building at its most stripped out stage. However, Keynote is not behaving itself. So at the end of the presentation, I'll show you the model. But we've done this at 2 different stages so far, and we're going to do it again once it's finished. So we've got a stripped out Matterport model, and we'll have a sort of work in progress where the upper floors are progressing along with insulation and plaster, and then the ground floor, you can see the membranes going in and the insulation going into the floor. And then the final version of the Matterport will be a finished flats. Here you go, done. And we'll come back to that at the end though. Okay, so this is just a little snapshot showing you on the left. This is what the stone was like when we found it. So that was all cleaned and repointed. The masons did a really good job on this project. And this is a very diagrammatic section showing you how the insulation that we've applied had to be continuous, reduce any thermal bridging. Otherwise, you can create serious condensation and mold risks. So this is the 2 external wall types that we used. So you can see the two top details are the existing. So it's your facing stone, and then you've got a chunky internal stone with a sort of rubble infill. And the reality is we don't know how many gaps and holes and little chimneys there are like within that wall. So the air tightness, as you can see on the lower 2, on the left, we've got the internal wall insulation version. So the line parge is applied to the stone. And then we used a natural hygroscopic wood fiber board fixed internally to the front elevation, which allows you to maintain that sandstone elevation, which, I mean, as Glaswegians, we all love and are incredibly proud of our tenements. They make the streets what they are. They make Glasgow what it is. So there's no way we'd ever want to cover that up with sticking insulation on the outside. So the wood fiber does that to the front elevation. It's all natural again, fully breathable, allows the stone to do what it does best. And then on the rear elevation, where the sort of heritage and the aesthetic of this tenement is probably less important, there's a payoff where we've applied EWI. And this is 200 mil of mineral wool with a silicon render finish. And EWI is much easier to install. It's much cheaper to install. And it performs a lot better than the internal wall insulation. And it also doesn't create moisture issues that the internal wall insulation does, which we'll come to. So this is the window details and how they work with the EWI and how they work with the IWI. And that's a couple of work in progress shots of the insulation. So on the left, this is the wood fiber board. So the stone has already been sealed with the line parge. That is then taped to all the windows to ensure it's all airtight before the wood fiber board is fixed through that into the stone. And then the finish coat on this is another layer of the line parge. So it's all fully breathable. On the right, we've got the mineral wool going on to the rear elevation. I've got a finished photo of that later on. IWI it's incredibly tricky. It creates a lot more issues than external wall insulation does. And if it's done badly, you can actually make the situation worse. If you think you're improving the building, you might create a dozen extra problems and not fix any of the ones you actually originally had. Anyone who hasn't been to read this book that Chris Morgan published, highly recommend it. It's available on the Pebble Trust website, download for free, or you can buy a copy, a physical copy for to be delivered to you. And it includes loads of really good 3D drawings like this. And it's just a really clear, easy to follow guide about retrofit. So we've insulated the walls, we've installed highly insulating glazing, and the next pieces of the puzzle are the ground floor and the attic level. So the way Niddrie Road has been done is that it's all one single enclosure. It's all one air tightness envelope. It's all one insulation envelope. So we've basically got a box without a top and a bottom. And this is what we're doing with the loft and the ground floor, adding the top, adding the bottom. So the loft level was getting 500 mil of mineral wool. And at that point, the plaster in your ceiling is the air tightness layer. So any penetrations through that are fully sealed with Proclima grommets you can get. And then at ground floor, the solum was quite deep, which is helpful, but not deep enough that you can get a whole person down there and do it all from underneath. So a lightweight timber frame is built, or like suspended from the existing joists, to give you enough depth to get, I think it's just over 300 mil of mineral wool, which sits in a breather membrane to prevent wind washing. And then an air tightness membrane goes over the top before you put down your board, your flooring board. While we were developing the details, we did a lot of therm analysis stuff. So we put in typical details. You see this detail all the time, where people just stop the external wall insulation, they insulate the floor, but then they don't do anything about the huge thermal bridge in the middle. And at this point, your skirting board is going to be cold, and that is where you're going to get condensation. If you've got moisture inside, people breathing or cooking or showering, whatever it is, it'll condense on that wall, it'll get damp, and then it'll grow a mold, and then you'll get a complaint from a tenant. So we did the analysis and accurately pinpoint where we need certain insulation to be. And it's about taking it right the way down to the foot of the foundation. And then we install a sort of French drain detail to keep it all draining properly. And we did have to maintain the airflow beneath the floor as well, which is while the breather membrane at ground floor was installed. If you ever see insulation installed in a net in the ground floor, I'd highly recommend against it, because it doesn't do anything to stop wind washing, which can actually reduce the efficiency of your insulation. So if it's just air moving across the surface of insulation, it won't perform as well. So that's why we would always use a breathing membrane for that. Again, making sure all these insulation pieces meet is really, really key. So we've looked at the ground floor to the wall, and then this junction was another really tricky one, which is where your internal wall insulation meets the loft insulation. And this is where the bay window is as well. So you've got like a little semicircle shape, which is being built up in PIR fixed internally. Obviously, it's much more energy efficient than a mineral wool product, and it's rigid. So it gives you a good fixing basically, and something to finish off internally. The other element to this detail, which is quite tricky, is that the ventilation line has to be maintained. So to vent the roof space, there's this little lead drip beneath the gutter, and like you'd never know it's there on site, but it's this tiny little route for the air to vent up. And then you've got the rafter roll keeping the air movement into the loft space. We also oversized our gutters, which everyone at JGA is very on board and committed to the climate crisis. We are all worried about it. We talk about it a lot. And one of the things that we're all aware of is that huge downpours are going to become more regular and worse probably in future. So with most of our projects, we tend to increase the gutter sizes from what they would have been maybe 15 years ago, just to protect us against this. So this is that detail that I've just shown you, the PIR downstand at the bay window. And that's it from the outside. The guys that did the LED flashing on this project were really, really good. I can't remember the name of the subcontractor, but exceptional work. And then we've got a similar detail at the rear. So obviously at this point we have the external wall insulation, and a PIR board is fixed over the head of the wall, which makes sure that that insulation line is continuous. But again, that we've got this little ventilation route into the loft space. again, the joiners that did this bit were meticulous, and it was absolutely beautiful work that they did. And it's a shame because no one will ever get to see it. It's all hidden away. So I mentioned before that internal wall insulation creates a lot of issues for us, and this is to do with moisture. So once you put IWI on, your stone behind that wall is then not being heated from your internal heating. So that wall is then cold, which means that the timber joists that are sat in that wall are no longer being warmed or dried. So they are they're at risk of rotting, basically. So we did a couple of detail options and looked at which one was the best in terms of keeping the relative humidity as low as possible in those joists, which is the lime parge, wood fiber lime parge sandwich build-up that we did. It did mean, though, to avoid that risk of rot for those joists, all the timber at the front had to come out of the wall, which gave us this really interesting detail where you had a big void up the whole building, and then at each floor level, it had to be non-combustible for fire. So we had a foam glass block fixed into the wall, then timbers fixed through that, and then everything was packed with non-combustible mineral wool. And that's done at each floor level to make sure your insulation from the loft all the way down to the ground floor is fully continuous, but you also don't have a fire risk. So everything was taken out up to the Bessemer beam, which is this big chunky beam which creates the semicircle shape at your bay window. And that's after the wood fiber's gone on, and you can just see the timbers sandwiched in between. So that's where you've got foam glass, and then the timbers fixed through that. We covered ventilation a little bit earlier. So each flat has got its own MVHR unit, which is all concealed above a drop ceiling. And in terms of heating, we've got 4 air source heat pumps and 4 gas boilers. There's a few reasons for that. The first is cost. The second is the research element. It gives us this really nice scenario where we can compare and contrast the old technology with the new. See how those 4 flats operate with the gas and how they operate with the heat pump. The third element to that was that your outdoor unit can only be 4.5 meters lower than your internal unit. And in the situation we have at Niddrie Road, the 4 external air source heat pump units are in the back court, and they can only get up to first floor. So if we wanted them to the top 2 floors as well, planning would have had to kind of meet us in the middle in terms of to go on the roof, to go on the wall, and they weren't having that. So there was never an option. This is the other second half of the video, which again, I'll come to at the end. So these are some recent photos from site. The project is nearly finished. There's been a lot of air tightness, remedial works ongoing, and lots of smoke testing to ensure everything that we've put in is as it is intended. So on the left here, you can see the stonework's all been renovated. On the gable, that's the external wall insulation and render wrapping round. We've got the new passive house rated windows in, coloured and proportioned as required by planning. They wanted that really traditional split of a tenement. And then on the right, this is the external wall insulation fixed to the back court, which actually it's so much tidier than what it was. It was a right mess of pipes and cables and everything before. So it's much neater. It's obviously, I think this slide encapsulates really well that balance that we have to achieve between retaining the heritage of the sandstone, but also meeting us in the middle and having the energy efficiency that we actually need to hit the targets we want. And then just a couple of internal shots. The interiors now, you would never know what's there. It's all covered up. And I mean, it's a bit of a shame, but the people moving in here, it is just a tenement flat to them. And if they're on board with sort of what we're trying to do, great. But there's no difference to living in this than there would be in a normal tenement. You've got an MVHR, you've got an air source heat pump, maybe. That's it. I'm nearly finished. The quick start guides are something we do for lots of our projects. We do a lot of monitoring of projects we've finished, and the main issues tend to come when someone moves in and they think, what's that annoying buzz from the MVHR or something, and they turn it off, and then 6 weeks later they'll have mold growing, and then they complain to the housing association. It's about a change in attitude and a change in behavior, and we do these guides as a sort of quick start. You can read it in 10 minutes. This is the sort of technologies that are in your home. This is how best to use them. And the two selling points for this is health and finance. If you use the home in the right way, if you live in it the way it's been designed, you're going to be saving a fortune. You're going to be healthier for it. And these flats, I think I didn't mention this earlier, which I should have. Originally, we're paying £100 a month in their energy bills. This is obviously 2 years ago, which it might be a bit more by now. But once finished, these flats will be paying £10 a month for their energy. There's such a little demand for the heating of these flats. So it's a 90% reduction in your fuel bill. And if that means having an MVHR above a drop ceiling in your bathroom, I think most people would bite your hand off of that opportunity. Okay, so that's basically it. Obviously, once the monitoring and things get disseminated, we'll make sure we get in touch with GIA, and they might be able to assist in spreading that. There's a few of the resources that I can send to James, and he can send out to the sign up list. We did this little fact sheet, which has kind of got some really key technical data on it. It shows how we've improved the layout. It gives you a bit of a description of some of the work we've done. And then there's two videos as well that we've done. One of them was just on our Vimeo, and it's like a little virtual site tour, and it's probably a lot of the stuff that I've covered this evening, so it's maybe not crucial that you need to go and watch that one. But there's another one that Cash did with the University of Glasgow, and that's on YouTube. If you just search Niddrie Road, it's near the top, and that one's really good. That gives you some really good background to the project. So that is it. I'll show you the Matterport model really quickly.
Thanks very much, Drew. While you're getting that video going, if anyone else has any questions they want to pop in the chat, then please feel free to, and then we can run through them following the Matterport videos. I can see Sam's put one in already. You can also join, turn your video on and talk, ask your question physically if you prefer. But yeah, either way, if you can start gathering your thoughts on questions, that'd be great.
Grand. So the first half of this video is the building at its most stripped out. And obviously, as you go through this, you can see the idea that we're going to keep the original ceilings, keep all the original plaster is kind of mental. So you've got the floor, 4 floors, and then I mean I think a lot of the issues came out of the fact we started just before COVID, and then the site was shut for like 6 months or something. And then when we went back to it, some of the windows are actually blowing in, and like once the weather had got in, ceilings started falling down and things. So it grew arms and legs quite quickly, and like things like the deadening in between the intermediate floors. Once the ceiling came down, some of that came in, and it was maybe 50% of that was replaced. So we've had to be quite flexible and quite reactive to the things that happen on site with this project, which I'm sure anyone dealing with a building that's 120 years old probably have the same issues. Also, the condition of some of the stone internally, obviously on our drawings, it's like a very vaguely wavy line, and you could have fit sort of full concrete blocks into some of the gaps that were in the stone walls. So yeah, I think in hindsight, I probably would have drawn the walls a bit more undulating, to we say. This is some of the wood fibre that was partially installed at the front. Chimneys in the party wall was also an issue. We weren't sure if they were still there or not. The fireplaces were all blocked up before that already. So it was something we had to react to. We ended up putting a insulated plasterboard over the existing flues. On the gable wall, we did manage to fill the chimney flues with EPS beads, but because we didn't know if the neighbours next door had fireplaces open or not, we couldn't risk filling their entire flat with EPS beads. No doubt we would have got complaints from that. So this is the ground floor's obviously been all taken out before they put the insulation in. As you can see, there's huge areas of that deadening that's already come in and it's been replaced historically. And then this little hole at the bottom left here, I love this. You could almost fit your head through this gap, and we're talking about the air tightness levels of Enefit, which is 1 air change per hour, which is it's a tall ask. I think your typical new build would achieve between 3 and 5. So to get this down to 1 has been a challenge, to say the least. So this is the second Matterport model that was done, which is a work in progress. So some of the upper floor flats are much further along. We've got the new windows in, they're all insulated and plastered, and I think they've even had first coat of decoration in some of them. This is obviously one of the top floor flats that's got a gas boiler. Regardless of which heating system was used, a small corner cupboard was installed in the bedroom to contain that. This is all manky old insulation coming out of the loft. The Matterport models were done by Mitchell at High Serve. If anyone knows them, they're really, really good. They've got this amazing 3D camera that they come around and they can do the whole building in a couple of hours. It's really worth seeing it done if anyone ever needs it done. We'll make sure that all 3 of these models are available as part of the research issue at the end. I didn't actually touch on the close much, but the close is the same as the flats. That's getting the wood fibre at the front, and then obviously external wall at the back. The original ground floor, ground bearing concrete slab was all dug out in the close, and a new insulated slab was laid to match the existing. This particular bay window with the brick, it's got steel angles and brick. This was the worst one by a mile. It was in such bad shape when it was opened up, and the structural engineer had to get involved and make sure it wasn't going to fall down on us. And then this little dungeon under this is knocked through from the flat into the little void beneath the close stair. Again, that had to be opened up so someone could get in to put an insulated slab in it and put wood fibre on the front elevation. Otherwise, it would have been a huge cold bridge and it would have leaked air. So this is the ground floor, which was done last. So obviously it's not as far along as the upper floors that we've just seen. Okay, I think that's me. Thank you very much.
That's excellent. Thanks very much for that, Drew. I'll start throwing some of these questions at you now, if that's all right. So
Okay.
we had a few questions around the budget. Are you able to share anything on the costs per flat or overall budget for the project?
I think it's roughly 900,000 last time I was issued a report. I would caveat that and say a lot of people have asked me that, and when you tell them it's £900,000 for these 8 flats, they do sort of jump back a little bit. But that total cost can be broken up into 3 elements. There's the building maintenance, and like just repairing the things that were not right already was a third of that. The other third was the energy efficiency stuff. And then the final third was the nice to haves, new kitchens, new bathrooms, new finishes. So it's really important that when everyone asks what the total cost was, that you give them that context, because otherwise people will just write it off as, we can't be doing this, it's too expensive. And it is expensive. I hold my hands up, it is expensive, but
Yeah, very high quality building at the end of the day.
Yeah, I think in terms of cost as well, I think the rarity of this scenario, of this single whole tenement owned by one body, because it's so rare, it probably isn't applicable at scale, I would say. But we've learned so much from it that could be applied at scale, and less cost. Sorry, my cat's trying to get in. You can't hear that.
Well, that's another question, actually. What are the key takeaways in your mind for other similar projects, or for other housing associations or authorities who might be considering a similar project?
I think it's quite a difficult question. That if we had 20 of these lined up tomorrow, we could just get to work on them and it'd be fine. But how you apply it to mixed tenure blocks, and I really don't know. Yeah, so I'm sorry, I can't give a better answer on that. We are doing some other projects around the corner that are to AECB standards, where we're just doing individual flats on those ones. So they will probably be more applicable at scale. But again, a lot of the learning that's come from Niddrie Road is already being applied on those. So I'm really interested to see what happens on those projects.
Good stuff. Another topic then about the internal air quality, and you mentioned making buildings more airtight, perhaps adding risks of trapping more internal pollutants. So question is, did you do anything in terms of the specification of internal finishes to reduce those pollutants?
Yeah,
maybe certain paint types
as many products as we can that we used are natural hygroscopic products that are breathable, and that will help to reduce the amount of toxins you have in the home as a start. But also the MVHR, because that's working constantly, it's constantly giving you fresh air from the outside. So if you do have a carpet, which from what I've heard, most carpets are toxic, even if they're natural, they're covered in all sorts of chemicals. Even if you've got a horrible carpet in your flat, and you've got an airtight flat, the MVHR is constantly refreshing that air. So the risk should be reduced massively by an MVHR. And obviously, if it's warm outside, you open your windows, you can still do that. I think a lot of people assume that with these buildings, you just never open your windows, but that's absolutely not the case. Like you can still open your windows.
That's great. Could you also recap on the PUE arrangement you've got? Is it monitored for 1 year, did you say? And what's actually being monitored?
Yeah, I think it's being monitored. All the flats are being monitored for a year. So as the work was going on, we installed, I think it's about half a dozen moisture monitors at key points. So at joist ends, on the line parge face internally. And then Tim Sharp and his team have got sort of valves fixed to wastewater heat recovery units and sensors on MVHRs, so they can monitor like how efficient are these technologies? Are they doing what they say they do on the box when they turn up on site? I haven't had much involvement in the research element of the project. Chris Morgan knows a lot more about that than I do. And probably the YouTube video is probably the best thing to go to if you want to know more about that.
That's great, thanks. Another question on the planning. You mentioned not going for air source heat pumps on the upper flats due to planning restrictions or complications. Did that come from the planners basically instructing you wouldn't be allowed to do it, or was it?
I think they were really concerned about the air source heat pumps in the back court as a start. So the 4 that we've got are screened with a little timber enclosure, little timber fence enclosure. I think they were worried that they were going to be set out and just look awful. And admittedly, they don't look great, the external units. They have a sort of air conditioning unit aesthetic to them. So that there was absolutely no way they were going to let us fix those to the building in any way. But to be honest, I don't think we could have afforded the extra heat pumps anyway. But there was some really interesting planning discussions on this that I never would have thought would be a thing. One was at the back court, the windowsills that we have, the big chunky ones that you may have seen in the photos. They're a pre-insulated GRP oversill, and they were a requirement by planning that we had to mimic the scale and proportions of the original stone sills. So originally we just had the aluminium sills that come with the windows, and they wouldn't accept that. So we did these insulated oversills. Gutters as well, with all the insulation and things going on at the eaves, they were adamant that the gutters had to sit in the same line relative to the neighbouring properties, which was fair enough. It just meant more tricky detailing.
Yeah, it's interesting that certain areas you think might not be crucial to be retained, or it's not in a conservation area or anything like that, is it?
It's not. No? It's on the boundary of another conservation area.
Right. Okay.
In one now. But I think they were very nervous. I think they saw this as a precedent. So whatever we agree to here, if there's another project like it down the road, they can just point the finger and say, "Oh, they got away with it." So
yeah.
I
wonder, it is strange, isn't it, that tension between trying to get to a zero carbon or lower carbon position, but the planner saying, actually, we're going to force you to put gas in.
Yeah. I mean,
was there anywhere else you could have put those heat pumps?
I think I've heard so many people say it, and we talk about it a lot, and just the fact that if you're making a building more energy efficient, there should be some sort of like planning procedure or policy that addresses that makes certain things doable. If we're all on board with this improvement that we need to make in our homes, and I thought maybe one of the legacy things from COP26 would be like some sort of planning assistance that would be put into place, but nothing's really happened yet. I think it must be in the post. So say you're making your house 10% or 90% more efficient, so you're only using 10% of what you were. There must be something there from a planning perspective that assists you in that, because I seem to just come across a lot of road bumps in terms of planning, which is very frustrating.
Yeah. Okay, I'm gonna have to rattle through a few more questions here in the time left. So got one on the build-up of the internal wall insulation, and would you have considered using something like Celotex? If not, why not? And,
so
and what was the actual product you did use, the manufacturer?
So Celotex, we did use a small amount of it to window jambs only. Obviously, Celotex, it has a much lower lambda value than the wood fiber, but it's not natural, so it wouldn't let the stone breathe. So that's why we use the wood fiber. Also, because the wood fiber is hygroscopic, if you've got high levels of moisture in your flat, although your MVHR will deal with that, the lime parge and the wood fiber absorb moisture when the moisture levels are high, and then once it returns to normal, they'll release that moisture. The wood fiber product was, I think it was a Pavatex Pavatherm, I think it's called. So it was 120 mil thick at the front.
That's great, thanks, Drew. Can you recall the window spec as well, and what material were they?
So they're timber frame. They are the Green Building Store, I think it's Ultra, and they've got the insulated core as well, which gives you a slightly better U value. And they came pre-painted white. So to be honest, they don't look timber, and they actually don't feel timber, but they're quite nice. They're quite pricey, but definitely worth it. They're really nice windows.
Did the building have PVC windows in when you came to it, or was
it was a real mix. The windows were in a really bad state, and there were probably I think every single flat was different in terms of age and what they were made of and how they opened. It was all over the shop. A lot of single glazing, some timber, some plastic. But I actually can't remember the split. But
okay, thank you. And question on if you were to try to renovate a single flat in a tenement, you mentioned you've probably got your whole block to 90% more efficient. Could you get to that standard if you were just doing the flat? What might the restrictions be that you come up against?
I think you could do a much improved flat. I think you could probably aim towards AACB standard, which is not quite as strict as Retrofit. I don't know if anyone's tried to do an Retrofit individual flat yet, but there's limitations because if you've got flats above and below you and next door on both sides, it's quite tricky because obviously you're only limited to the bit you own, so you can't really do anything with your joist ends. So if you're putting lots of internal wall insulation on, you might be creating issues that you can't actually solve from a ownership perspective. I can't remember. Is it Lisa Pasquale? She did a blog and a couple of presentations on her flat she did, and it was brilliant. I can't remember who it was. Sorry, can't be more helpful on that one.
Oh, thanks anyway. Yeah, I think it was Lisa. Cool. I had a few questions myself actually. So what actual size were those MVHR units? Was it a meter square or smaller than that?
They were the actual dimensions of the unit?
The unit itself, yeah.
Yeah, I think they were about 700 by 900 mil or something like that, and maybe 300 deep. It was the Zender Confo Air 160, I think, that we used in all the flats. It's a relatively small one, I think, compared to some of them you can get.
Yeah, I haven't seen any for flats before personally, only for sort of a whole house, which was the size of a fridge. So great, you can get smaller ones. So would that do for, say, how big are these flats? 80 square meters or?
I actually can't remember off the top of my head. I'd probably do your 1 or 2 bed flat. I'd imagine if you go 3 or 4, you might need bigger.
And the other question I had was on, you mentioned at the start, the solar gain not being optimal for the building. So in your Retrofit analysis, what did you find when you were sort of running the calcs as the major draws on the energy? Just remember in PHPP, you get that quite good graph of where the energy's sitting and what ends up being the biggest hotspot, I suppose.
For gains or for losses?
Well, both, I guess.
Actually, not sure. I'm not sure. All I know is that the window orientation was limiting, and obviously the size of the windows were always going to stay the same as they were as existing.
Yeah.
The only thing that we did to maximize that solar gain was at the rear we had to the bedroom windows. There was two windows with a concrete mullion in between, and we originally proposed to take the concrete mullion away and have a single huge window. And again, this was which would have been the best, because obviously you've got less thermal bridging then, because you've got less jam, and then you've got less frame as well. But planners were adamant that we had to keep that split. So the back window stayed as a single window, but it did have a central mullion in it. So that helped us maximize the solar gain. But sorry, it hasn't massively hasn't answered your question very accurately. I'm sorry.
That's fine. I guess I was wondering, is there certain locations you think anything wouldn't work, or you think you'd end up being able to apply it to any location?
Yeah, I can imagine if you were sticking to tenements, if you had a basement tenement as part of your block, I mean that must make it almost impossible.
Yeah.
Or if you're doing just an individual basement flat, that must be really difficult.
Yeah, sure. Okay, I think I have covered all the questions here, quite a few in here. So last chance for anyone to speak up if I missed one and you're desperate for an answer. Other than that, I'll just say thanks very much, Drew, for presenting this to us. Very interesting. We'll get the video on our website. And yeah, we've got a few actual building visits coming up through GIA, so you can look out for those on our social channels. And yeah, Isabel, is that a question coming from you? No, just saying hello. Great. Okay, I think I'll just end it there. So thanks everyone.
Thank you, guys.
And good night.
Cheers, thanks all. Thanks for having me.